Sejahtera and good day. My name is Jiwan Jayadanan. My metric number is CE210092. Here I would like to present about our group project for the title of First Order Differential Equation to solve RL circuit. We are from group 2 and now I would like to present on the introduction part. In this project, the ODE is a mathematical solution to solve and find value in circuit design. There are different types of ODE, which are first order differential equation, second order differential equation, or system of ODE. Besides, there is a required tool to find the value on the circuit design, which is by using MATLAB software, which we are using in this project. Most elementary circuit system can be modeled as differential equation. The first order differential equation will model a simple RL circuit in first order differential equation and solve them using the methods of solution which we learned in previous section. Next, about the problem statement. This project is more to the application of electronic and electrical circuits. The circuits involve RL circuits which we choose. The circuits that need to be calculated through the ODE calculation. After calculating through manual calculation and need to be converted in code. The code needs to be set through MATLAB software and show the proof step by step. The part that needs to be solved in this project is to make the design related to the manual calculation. Then the calculation need to be related and converted into a code on MATLAB software which we use. The purpose of this project is to make the auto calculation of ODE based on circuit structure. By using this software, it will be easy to auto calculate when using the different values of respective circuits. Next, on the background part, many of the principles in science and engineering concern relationships between changing quantities. Since rates of change are represented mathematically by derivatives, such as principles are often expressed in terms of differential equation. Many fundamental problems in engineering are described by differential equation. To formulate and use the equation in the universe system, first we have to spot the real-world problems that require an answer, then make some simplified.
Assalamualaikum, my name is Sharifah Akila binti Sa Ahmad Tarmizi and my metric number is CE210081. So today I'm going to present about the formulation of model. The model formulation that we employ in this project is an RL circuit. An RL circuit is also known as an RL filter or RL network. Is an electrical circuit made up of the passive circuit elements of a resistor and an inductor connected together and powered by a voltage or current source. So consider a basic RL circuit with a resistor and an inductor linked in series with a V volt supply. We may derive a first order ODE from this RL circuit by using VL equal to L, DI dt, DI over dt, and VR equal to IR. Okay, next is method of solution. So to accomplish this simulation, we use the MATLAB software as the main application. We also utilize various electric circuit formulas to compute the circuit current and voltage. As you can see, in the manual calculation, we apply the formulas to get the output value. With this, we were able to get the identical simulation outcome. That's all from me.
My name is Muhammad Zamani Amni bin Muhammad Zani. My number metric BE11203 and I am from Group 2, Section 5, ODE. For today, I want to present you about the solution and result. We have three things I want to present to you about the manual calculation, analytical using mathematical tool, and plot of solution. For manual calculation, we use the RL circuit, which are voltage source 20 volt. For inductance, we use the value of 0.5 H Henry, and for the value of resistor we use the 10 ohm. Okay, go to the manual calculation. For manual calculation, this is the circuit that our group designed for solve this problem. Okay, for the problem, it want to search for the total current IT, which initial condition IO equal to 0. Okay, for the solution, we use the first ODE solution to solve this circuit for to get the total current IT. For first, we use the formula VL plus VR equal to V. VL is L di per dt plus VR is IR, I multiply R equal to V. Okay, we enter the value for the L, R, and V. For the for the each for the each value, we must multiply 2 to eliminate 0.5, and we get di per dt plus 20I equal to 40. Okay, this is we use the ut equal to exponential integration 20 dt equal to exponential 20t. This is we must get this for this formula from this 20i. Okay, after that, di per dt plus 20i equal to 40 must be multiplied with exponential 20t. After we multiply all of them, we get the result x. We can see this. Okay, after we get the result, we must integrate for the both side. After integration, we get the e exponential 20t multiply I equal to 40 per 20 integrate e u du. For those not know how we get u and du, this is the formulation we must do to search u and du. Okay, this is u equal to 20t. We get the from this one for the from the exponential 20t, we get the u, and du is equal to 20 dt. Du for we can get the dt for the this one is du over 20, and we get the 40 per 20 integrate eu du. Okay, after that, e 20t multiply I equal to 2 exponential 20t plus c. For those do not know, integrate for exponentials must have plus c. After that, we must search for the I. So I got this one exponential to go and divide it for the 2 and plus c, and we get the 2 exponential 20t divided e exponential 20t plus c divided e 20t, and we get the it equal to 2 plus c e negative 20t. I got e 20t to go to upside, and we get the negative 20t. And at the start of the question, we get the initial condition IO equal to 0. So we enter the value, and we get the C. We get the value of C is C equal to negative 2, and we enter from this value C in this equation, and we get 2 minus 2e negative 20t. This is for manual calculation. For the RL circuit, that we choose the value and we design the circuit. Okay. For the analytical using mathematical tool, you must use the MATLAB coding. After we boot the coding must show how to get the answer, and for the graph. This is the coding we boot for get to get the answer. Seems IT L equal to 0.5, R equal to 10, V equal to 20. This is for the MATLAB coding, and I can show you how to use the MATLAB in the next present. Okay, and this is for plot of solution. This is current versus time. Current A over versus time. This is plot of solution after we execute the MATLAB coding for to search the uh, the answer for the RL circuit. Okay.
A few moments later.
Okay, for this section, I show you. I copy the MATLAB coding that we boot for execute to search the answer for the RL circuit. We use the L 0.5, R equal to 0 at 10, and V equal to 20. And this is equation 1 that I show you in the manual calculation. And IT is equal to deal solve to find and solve for the equation 1. This is a display IT for display the answer IT. Same C1 is for the C we used to search the value of C. IT equal to subs IT C1 2. 2 is the value we get in the previous equation. Display IT f plot IT grid. We use this to find the plot of solution. Title current I versus time T, X label time S, Y label current A. Okay, for this I execute and run the MATLAB coding, and finally I get the answer is C1 exponential negative 20 plus T multiply T plus 2, and the final answer is 2 multiply exponential negative 20T plus 2. This is exactly like the manual calculation, and after that we get the plot of solution. That is from me, and now we move to the next present.
My name is Benjamin Hohausian. My numerimetry is C210053. Today I would like to explain about the summary and discussion part. For the RL circuit, it includes a resistor, inductor, and a voltage supply. And for the series circuit, I is equal to IR and IL. So all the current is the same. And for the voltage is we're using the Kirchhoff voltage law, and the formula is VL plus VR equal to V. So the VL is equal to L multiply DI per DT, and VR is equal to I multiply R. So for the final formula is L multiply DI per DT plus I multiply R equal to V. For next step, we're using the integrating factor formula, which is micro T equal to exponent power integration VR dt. So for the VR value is taking the constant. So I giving a example. If the VR is 20i, so we take is micro t equal to exponent power integration 20 dt. Okay. Our next part is the discussion. So we solve the circuit by using formula VL plus VR equal to V, and the VR is equal to L multiply di per dt plus IR equal to V. The value that we use, VT is 20 volt, R is 10 ohm, and L is 0.5 hash. So we replace the value inside the formula, then it will become 0.5 multiply di per dt plus 10i equal to 20, and we all divide by 0.5, and it will become di per dt plus 20i equal to 40. Then using the integration factor formula, as summary said, exponent power of integration 20 dt then will become exponent power of 20t. So from this equation multiply with the ut, which is exponent power of 20t, it will become like this: exponent power of 20t multiply with the di per dt and plus 20 exponent power of 20t multiply with the I and equal to 40 exponent power of 20t. So we solve, we take out the d per dt, and it will become di per dt multiply with the exponent power of 20t multiply I equal to 40 exponent power of 20t. So we integrate both sides, it will become exponent power 20t multiplied with the I equal to 40 per 20 integration exponent power u du, and we solve it and we become exponent of 20t multiply I and equal to 2e power of 20t plus c. So we all is divided by the exponent of power of 20t, and the final value we get is I t equal to 2 plus ce power of negative 20t. So for initial conditional, I equal to 0, so it will become, so we need to find a c and become c is equal to -2, and we replace the c into the equation and become the final value here. So we need to take out the 2, and it will become 2 multiplied 1 plus e exponent -20t. For next is a reference. There's 5 reference that we use, and that's all for listening.